Hey guys, in this video I'm going to run you through an introduction to stratified sampling, and we're also going to go through some exam type questions on it as well. So let's get going. So before we start worrying about stratified sampling, let's remember what population and a sample actually mean. So a population is the whole group of whatever that you want to know something about. So the population is the whole group. So, for example, we could talk about the whole population of the UK. We could talk about the population of your hometown. We could talk about the population of the whole world if we wanted to. Now, if we do that, we are certainly talking about rather big numbers, and it's quite impractical to ask every single member of a large group a question. So that's why we take samples. Now, a sample is a selection of a certain proportion of your overall population. So say we wanted to know how many people in the whole world liked chocolate. Instead of asking 7 billion people, which as I said, pretty impractical, we might take a sample of 1 billion maybe. Even then, that's still quite large, but it's much more practical to take a sample of 1 billion compared to a population of 7 billion. So the reason that we take samples is to make data collection simpler and, more importantly these days, cheaper. So a nice little way of picturing this is down here. If this red rectangle is our whole population, then the green ellipse inside of it is a sample of a certain proportion of the rectangle. Cool. Okay, so there are two types of sampling. I'm going to run over the other one as well, and we're going to go over that one first, in fact. So the first type of sampling is called random sampling. So consider this example here then. So 500 people are watching a film at the cinema. There are 240 men and 260 women. The manager wants to know if the film was enjoyable, so decides to ask opinions of a random sample of 20%. So, how would Mr. Manager do this? Well, there are 500 people watching the film altogether. He wants to sample 20% of them. So he would first of all find 20% of 500, and he would find that to be 100. So that's as far as his complicated background maths would go. He now knows he needs to sample 100 people, and he's doing it randomly. So how could he do this? Well, he could walk around with a blindfold and just point at 100 people. That would be quite random. He could be a bit cleverer and use a random number generator. Say if these people are in the seats from 1 to 500, he could set up a random number generator to get 100 random numbers. That would get him a selection of 100 random people. So, when you do random sampling like this, it doesn't take into account the different groups within the population. So here our different groups would be men and women. Random sampling doesn't care about that distinction. It might be that we end up with 100 women being sampled. We might end up with 100 men being sampled. We might end up with a completely even split of 50-50. It's very unlikely, but it might happen. So, when he takes this sample, there could be any number of women and then the corresponding number of men to make it up to the 100 that he desires. So when we do random sampling, every single element within the population has exactly the same chance of being selected. Now, stratified sampling is a little bit different, otherwise it'd be called the same thing. So, let's consider Mr. Manager again. So we got the same 500 people watching the film. This time though, the manager decides that instead he wants us to take a 20% stratified sample. Now, stratified samples do take into account the different groups within the population. So here stratified sampling would go, right, so we've got a certain amount of men and we've got a certain amount of women. we are still going to end up with 100 people in our sample, but there's going to be a fixed proportion from men and women. So, what we need to do, if we're taking a 20% sample overall, then we need to sample 20% of the men and 20% of the women. So, for the men, 20% of 240, well, 10% would be 24, so 20% is 48. So we would sample 48 men, and then 20% of the 260 women, you can probably guess already. So 20% of 260, well, 10% is 26, 20% then is 2 times that, which is 52. So if we were to use stratified sampling here at 20% sample size, then we would sample 48 of the men and 52 of the women. So once we know the number that we're going to sample from each group, we would then just do it as a random sample. We would sample 48 random men and 52 random women. So again, random sampling does not worry about different groups within your population. It just takes a sample of any combination of your groups. Stratified sampling takes a sample of exactly the same proportion from each group. Not the same number, the same proportion. So in this example, we sampled 20% of both the men and women groups. Okay, let's get cracking then with some exam type questions. Okay, example 1. The table shows the number of students in each year group at a school. Jenny is carrying out a survey for her GCSE mathematics project. She uses a stratified sample of 60 students according to year group. Calculate the number of year 11 students that should be in her sample. So already then, we are told the sample size. So she's sampling 60 people out of the entire population. So what we need to do then is find the size of the population. So we need to add up all of those numbers there. When we know the size of the population, we know the sample size that she's taking, we'll be able to work out what proportion of the population she is sampling. When we know the proportion of the population she's sampling, we take that proportion of each of the different groups. So, if we were to add up all of those, obviously feel free to use your calculator, we would get the population size is 750. So, the total number of people in her school are 750. That's our population size. Now we know that our sample size is 60. So to work out the proportion that she's taking a sample of, we do 60 divided by 750. Now if you put that into your calculator, that cancels down to 2/25. So that's the proportion of the whole school that she is sampling. So to work out how many year 11 students here she should sample, we find that proportion of the number of people in the year 11 group. So we would find 2/25 of 130. Now on your calculator you would do that as 2/25 times 130, and that would give you 10.4. Now obviously it doesn't make sense to sample 0.4 a person, so we would round that down and say that she should sample 10 people from year 11. Job's a good one. Okay, example 2. A school has 650 students. Each student studies one of Greek, Spanish, German or French. The table shows the number of students who study each of these languages. Okay, So an inspector wants to look at the work of a stratified sample of 70 of these students, find the number of students studying each of these languages that should be sampled. Okie dokie, so the two things we need, first of all, we need the population size. So that was given to us at the start. A school has 650 students. Now we also need the sample size. Mr. Inspector Man wants to look at the work of a stratified sample of 70. So the sample size is 70. So as a proportion, we are studying 70 650ths of the school, which simplifies down to 7 65ths. So now all we need to do, we now know the proportion of each group to sample. So we work through the table, and we first will do 145 times 765ths, sorry. Now that will give us, to one decimal place, 15.6. Again though, it doesn't make sense to have 0.6 per person. So we're going to say then, of those people, we're going to sample 16 of them. Round it up to the nearest whole number. So we're going to sample 16 people that take Greek. Then for Spanish, we're going to do 121 times 7 65ths. And to one decimal place, that just leaves us with 13. So we're going to sample 13 people that take Spanish. For German, I'm running out of room here with the writing. We do 198. I'll do it down here. 198 times 7 65ths. Now to one decimal place, that gives us 21.3. So we'd round that down to 21. So we're going to sample 21 people that take German. And then finally, for French, we're going to do 186 times 7 65ths. And that to one decimal place gives us 20. So we're going to sample 20 people that take French. So at the end, once you've done all the complicated stuff, make sure your separate samples add up to the total sample we're going for. So 16 add 13 is 29, add 21 is 50, add 20 is the 70. So again, we're going to sample 16 Greeks, 13 Spanish, 21 German, and 20 French. Jobs are good in. Okay, example 3. This one's quite a nice one, although there is something in here where they're clearly trying to trick you a little bit. So there are 500 boys and 500 girls in the school. Bob took a stratified sample of 50 girls by year group. Work out the number of year 8 girls in his sample. So be very careful on our population here. We're being told that Bob takes a stratified sample of 50 of the girls. So the only part of this table that we're interested in is the girls. We're not interested in the boys. The boys are not counting as part of our population because we are only sampling the girls. So our population size, question tells us, is 500 girls. So our population size is 500. Our sample size, we want to sample 50 girls. So our sample size is 50. So then the proportion that we are sampling, sample 50 divided by population 500. And that really nicely simplifies to 1/10. So we want to sample 1/10 of each of the girls' year groups. So 100, 1/10 of 100 is 10, 1/10 of 50 is 5, 1/10 of 100 again is 10, 1/10 of 150, 15, 1/10 of 100, 10, and then 1/10 of 500 at the bottom of the table. Be very careful here, remember, that's our population. So 1/10 of that again is 50. Now we just need to make sure that our above numbers add up to 50. So 10 add 5 is 15, add 10 is 25, add 15 is 40, add 10 is 50. Ideal. So when Bob takes a stratified sample of 50 of the girls, he should have 10 year 7s, 5 year 8s, 10 year 9s, 15 year 10s, and 10 year 11s. Jobs are good 'em. Okay, the final example for this video then. It's quite a nice one, although there is a little twist in it. So the grouped frequency table shows information about the weights in kilograms of 20 students chosen at random from year 11. There are 300 students in year 11. Work out an estimate for the number of students in year 11 whose weight is between 50 kilograms and 60 kilograms. Okay, so remember, the whole point of taking a stratified sample, or any sample in fact, is that the information about your sample gives you a rough estimate of that same information about your whole population. So here we're interested in an estimate of the number of students in year 11 whose weight is between 50 and 60 kilograms. So looking at the sample, what proportion of our sample was between 50 and 60? Well, it was 7 out of the whole 20. So as an estimate for the actual number of year 11s whose weight falls between 50 and 60, we want to find 7/20 of 300. Now again, whenever you're dealing with fractions and you're finding a fraction of an amount, think of that as that fraction times that amount. So we want to find 7/20 of 300. Now that's going to give us 7 times 300 is going to give us 2100 over 20. Now we can cancel out the 0. 210 divided by 2. 210 divided by 2, 105. So the estimate for our number of students whose weights are between 50 and 60 is 105. Cracking. Now there is another way that we can think about that. Let's see. So what we did, let's just get rid of this. This answer down here is absolutely fine. I'm just going to show you another way to do it. Okay, so let's think of it more along the lines of stratified sample. So what was our population? It was 300. There's 300 students in year 11. The sample that we took was 20. So the proportion that we sampled was 20 out of 300, which can go down to 2/30, which can go down again to 1/15. So to get back from the sample sizes in the table, we would multiply by 15. So in the first row, we would do 7 times 15, which again gets us 105. In the second row, 8 times 15 will get us 120. In the third row, 3 times 15 is 45. And in the last row, 2 times 15 is 30. Now if we just make sure those numbers add up to 300, 105 and 120 is 225, add 45 is 270, add 30 is 300. So again, the answer that we wanted, we just wanted an estimate for the number of people between 50 and 60. There's our 105 again. Remember, the reason it's an estimate is because we are using the sample to estimate information about the population. Okay guys, that's stratified sampling. Hope it's helped you. Was this video helpful? If so, don't forget to hit the thumbs up button and leave me a comment letting me know how you get on. Also, don't forget to subscribe to the channel so you never miss any videos. For any further information, you can find me on Facebook or Twitter. Search for Maths with Melv. Cheers, guys.